Hello dear students, today I will discuss about Adams-Bashforth method, that is a predictor character method. Just in the previous class I have already discussed about Milnes predictor character method. Now Adams-Bashforth predictor character method. Predictor character method, just by using predictor formula, we predict the value for y at some particular value of x in the next interval, and after prediction, just that value we have to correct by using corrector formula. So due to Adams-Bashforth, there is formula for prediction and for correction. Correction, first time just predict value and then we will correct the value one time, two times, three times. Whenever two corrections are same value, then we can suppose that is the final value. Okay. So here just the same type of process as in Milnes predictor character methods. So we will require 4 prior values of y for finding the next value of y. So just for prior 4 values, in the given equation we are given only one value, dy upon dx equals to fxy. This is our given initial value problem. That is, just one value is given, and this is first order differential equation. We have to find the solution of this for a particular value of y. This first value is given, but we require 4 prior values. That is first value. Remaining 3 values we can find by using any of the previous method, just like Milnes method. Generally, Ranga-Katta method will give more accurate result at the time of Adams-Bashforth method. But you can get the prior values by using Euler's method, Euler's modified method, Taylor's method, and just like this. Suppose here this is x0, okay, and suppose we are want to find at value, just here value of y is what? y0, okay. It may be origin, may not be origin. Clear? And our targeted here y0, our targeted value is what? yn. This we will find. This is, suppose this value is given and targeted value. For the value of xn, we have to find the value of y. But this interval, if big interval, then we can divide this interval as equal step, just like this. Suppose length of interval is h. For example, suppose values are given at 0 point and we have to find point 1 at point 2, point 3 and so on up to 1. So we can divide this interval, or for this point for finding value of y, we know in each interval we can use Ranga-Katta method, and at any other methods Because in the previous methods, before the predictor corrector methods, just we see that only single value is used and that value is at the beginning of the value, and for next value we can use this value repeatedly. Here we get approximation and final approximation is gives the value at here and like this. So we can divide this interval. Okay, so just first value is given, we require again two values. Here y0 given, y1 require, y2 require, y3 require. These three value we can find by any of the value. So here just for solving questions we will use Ranga-Katta method. Ranga-Katta method for Adams-Bashforth method gives very accurate value, most of the accurate value. Okay, you can use any other method also for finding the value of y1, y2, y3. Clear? So here, how can we get predictor formula due to Adams-Bashforth corrector formula? So here, just we are given values, equation is this, values are given just like y0, what is this? y0 is equals to x0, y1 equals to, just we have to find y1 equals to, y1 means what? y1 means x1, x1 means what? x0 plus 1 time h, and y2 means y at x2, means here x0 plus h, this is x1, at this point you can get y1, and similarly final value, this is what? x0 plus nh, that is xn, at this point we can get value. Here x2 means what? x0 plus 2h, and similarly y3, because 4 value are required for predictor and corrector formula. Okay, so this value here yx3 equals to what? yx0 plus 3h. Just we have to find this 4 value. This value is given and these 3 values we have to find from by using Ranga-Katta method. Okay, here or any of the method, Euler's modified method, Euler's method, Picard's method, Taylor's method. After finding these values, we use predictor corrector formula. So how can you find predictor corrector formula due to Adams-Bashforth? So just we have seen that in the Milnes method, Milnes predictor corrector method, for finding the value of y4, just next value. What is next value? y4. So for finding y4, we have used y4 equals to y0, and just by using this x0 to x0 plus h, 4h, fxy, in this formula just we use what? Newton's forward interpolation formula. Because these values are fine, then we can prepare a Newton's difference table, and by using diagonal values of differences we can find further value just after interpolate we can get. So here we use in the Milnes method Newton's forward interpolation formula. In this method just use here Newton's backward interpolation formula. For backward interpolation formula, we know whenever we prepare the table, this and this value are difference table like this. So forward differences gives this are the diagonal are the differences, and backward from backward side. So our notation is different. Will be different for Adams-Bashforth formula. Okay, here notation only. Values is this. Just we give different type of notation because here we will use backward interpolation formula. backward interpolation formula we know, just like suppose for creation of table, just we use what? Here values of x, y, here x0, x1, x2, x3, just like this. But for entry of this value, here use up to, we are having 4 values. So we use here 0, y minus 1, y minus 2, y minus 3. For x equal to this, 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 x equal to this. For x equal to 0, 1, 2, 3, this. For this value, just we have to denote like this notation. And these are the previous 4 values. Just give the notation for that. And just after this, y1, y2, y3. These are the. And we can prepare the table. Then backward differences leading like this. Differences at this, and forward differences leading values are here. That's why we are giving notation like this: y0, y minus 1, y minus 2, y minus 3, and so on. Okay? And these 4 values we have already known. So for finding y1 in the Milner's methods, just we have to find y4. Here we have to find y1 for next value, because these are denoted like this. Okay? So here just we use notation just like this. Here y0 means x, means x0 minus 0 into h. Clear? Y minus 1 means minus h. Y x minus 1h. Here y minus 2 means y x0 minus 2h, and y minus 3 means y x0 minus 3h. Just we are denoting like this. So we have to find the value of y minus 1, y minus 2, y minus 3. This will be our notation. Just these values are written in table like this. So next value will be y1, y2, y3, and so on. So values will be just like this. Here y minus 3, here y minus 2, here y minus 1, here y 0, and then y1. So we will find y1 by using predictor corrector formula. By using these 4 values. Okay? Here minus h, x0 minus 2h, x0 minus 3h. Clear? And so on. Just this type of values. Minus 3h is here, sorry. Here x0 minus h minus 2h, here x0 minus 3h. This type of notation. Clear? So we have to find y1, value of y1. At all this point, just like predictor corrector formula we know, after finding the values of x and y, we will find f, value of f. Here f means, after finding this, we will find what? f0, f minus 1, f minus 2, f minus 3. Just all values we have to find by using this. Value of x is this, y is this. After finding the values of this, because these are the x, value of x 0 minus h, x0, x0 minus h, x0 minus 2h, x0 minus 3h. These are the value of x. This is value of x, this is value of y. By using these two values, we will find the value of f from here to f0. Similarly, for f, y minus 1. So, using this value of x and this value y, so by using this, we can find like this. So, we will find like this value, okay. So, here, what we have to find? f0. f0 means what? f0, just like what? x0 and y0. Here, it means what? x0 minus h, y1. Here, it means what? x0 minus 2h, y2. It means what? x0 minus 3h, y3. Just we have to find these values. And from here, just like Miller's predictor corrector formula, we will use this. There was the value f0, 1, 2, 3. And here f0 minus 1, minus 2, minus 3. So previous values. Okay. And we are writing these values just in backward direction. Y minus 3, y minus 2, y minus 1, y0, and then y1. So our next value will be y1. So for finding value y1 is equals to what? y0. Just previous value. We will write like this in backward word. Y minus 3, y minus 2, y minus 1, y0, y1, y2. For this, using this value, for this is the previous value. So y0 plus integral x0 to x0 plus h and fxy dx. This is our. In this formula, here we use Newton's backward interpolation formula. y0 plus just x0 to x0 plus h. Backward interpolation formula is what? For f. Backward interpolation formula we know just like this. F xy equals to, for f, because value of f, for f we can write f of 0 plus n del f of 0 backward, n plus n plus 1 upon 2 factorial del square f0 n plus 1 n plus 2 upon factorial 3 del cube backward. Because in this table, backward difference will be in this direction. So, y0 means f0 means at f0. This value will be used here. Just like this, f0 plus n backward del f0 plus n plus 1 upon 2 factorial backward difference at f0 and so on. Dx. Now, just like previous, because derivation is not required, just we will remember the formula. What is the predictor formula? So predictor formula we can get just like, first of all, this difference, just like this del f0, forward difference. Forward difference, this is means what? Del f0. Del f0 means this can be written, means all the difference, backward difference, first order, second order, third order, fourth order, and all the differences can be expressed in terms of functional value. Functional value means it can be written like this, f0 minus f minus 1. Because difference, how can we get the difference? This minus this, this minus this, this minus this, this minus this is known as backward del difference. First order at 0, and after this minus this, del square f0. So This can be written as f0 minus f minus 1. Similarly, second order difference can also be expressed in the terms of functional values. And third difference also can be expressed as functional values. After expressing these derivatives in terms of functional values, just integrate and apply the limit, then you can get formula. That is the predictor formula. Okay? Or take up to third order derivatives, difference. Okay? So formula will be, what will be the formula? That is main thing. Just you have to remember that formula, y1 equals to. Okay? So note down the formula, very important formula, because if you can write, then you can find the value very easily, because formula should be right. Here formula, Adams-Bashforth predictor formula. Adams-Bashforth predictor formula. Clear? After this process, we can get. Formula is y1 equals to, predictor formula, that's why we denote like this, yp is equals to y0 plus, remember this thing, okay, y0 plus h by 24, h upon 24, and in bracket 55 f0 minus 59 f minus 1 minus 59 f minus 1 plus 37 f minus 2 plus 37f minus 2 plus 37f minus 2 minus 9f minus 3 minus 9f minus 3. So this is formula. Just remember this formula. Adams-Bashforth predictor formula. This requires previous 4 values. f0, f minus 1, f minus 2, f minus 3. f0, f minus 1, f minus 2, f minus 3. This value can be found by using format of this is given fxy. So just apply this format for finding this value. For this require x0, y0 which is given, and for x0 minus h, y0, h will be the step interval, length of the interval. So just we have decided that what will be the value of h. So it can be at this point you can find y minus 1 by any of the previous formula, either any of the formula. So just get this value at this we can find, and all 4 values are used here: f0, f minus 1, f minus 2, f minus 3. Here 55 minus 59, 37 minus plus. So just remember this formula. This should be right, okay? And this is predictor formula due to Adams-Bashforth. And this, after predicting, just next value, after this next value, it will be right in backward direction. So y minus 3, y minus 2, y minus 1, y0 and y1. For y1, this is the prediction. Because you can put here y0 and all the values and h, you can get value. That is the value of y1. For x equals to what? x0 plus h, this is the value of x, and y1 is the predicted value. For this value, we can find f1. f1 means this x1, x1. this y1, y1. So y1 comes from this prediction value, predicting value. Okay, and we can find f1. Now, for the corrector formula, just this value is approximation and y1, and these values now we will refine this value by the corrector formula. So we can get first correction, second correction, third correction. Whenever two correction gives same value near about, then we can say that is the final value of y. For next value y1, we can use repeatedly corrector formula, not predictor formula. Predicting is this. For correction, for getting the correction, corrector formula due to Adams-Moulton was here Adams-Bashforth predictor formula, and corrector formula Adams Adams-Moulton corrector formula. So that is Adams method, Adams corrector formula. This formula can also be get by using just like same method, just previous method, by using Newton's backward formula, just as same process. Newton backwards formula, just like this, fxy equals to f1 plus n backward del f1 plus n plus 1 by 2 del square f1 means at the index f1 1 1. Just previous for the predictor formula we have used what? f0 0 0 at 0 point. For correcting, just use one line ahead, just like this. What? Table y0, y minus 1, y minus 2, here y1. These differences are used for prediction formula. And now for correction formula, these differences are used because for next test. So this formula can be used for getting correction formula. And same process up to take up to third order difference and just write all the difference first order, second order, third order in terms of functional values and do the integration. We can get formula as correction of y0 plus h upon 24 here. Just note down the formula. 9f1 9f1 plus 19f0 plus 19f0 minus 9f1 plus 19f0 minus 5f minus 1 5f minus 1 minus 5f minus 1 plus f minus 2 plus f minus 2. This is corrector formula due to Adams-Moulton corrector formula. Okay. So y1c, y1p. y1p is prediction. After prediction, the value of y1, just this value get on the point what? x1. That is x0 plus h. We know this, we know also this. So x0, x1 can be found. And here y1 is prediction value, this prediction value. Okay, by using these two values, x1 and y1, we can get the value of f1. Value f1 by using this. So that is the what value? f1. Now this f1 is used here. Here not f1 anyway. So at this stage, this f1 is used here. f1. And f0, f minus 1, f minus 2 are f0, f minus 1, f minus 2 are this. Just f1, f0, f minus 1, f minus 2. This 4 values are used. Just previous 4 values. Previous 4 values. And h you know. And y0 also know. Clear? So this is correction formula. So by getting f1, just use f1 here and all the previous values. We can get first correction. And for second correction, just first use corrected value. Again use this corrected value y1c. First correction, suppose this is. So first correction value use and x1. So we can get value by using this formula, that is f1. Again f1. This value is found from corrected value at first instance. So this f1 again use in this formula. Then we can get second correction. We can get second correction. This is first correction, second correction. And after getting second correction, we can also do the third correction. By using this y1 and x1, we can get value f. Again f1, we can get new f1. Use this new f1 again this in this formula, then you can get third correction. So just like first correction, second correction, third correction you can do. And if two corrections give near about same value, that will be the answer. Okay. So this is correction formula. Corrector formula due to Adams-Bashforth. Okay. So this after finding the previous 4 values, just we will find next required value of y. Okay. Okay. So this is the method of Adams-Bashforth Predictor Corrector formula. Predictor corrector method. Adams predictor corrector method. Okay. So now we will take some questions, but questions are very lengthy because numerical mathematics you have to do calculation by using calculator. It can be computerized, you know, also. So just now I will solve one questions. Remember that for getting previous values at the time of Adams-Bashforth method, just we will prefer Ranga-Katta method. That will give very accurate value of y. Okay. So just take questions. Also you can use any of the method, Picard's methods, Taylor's and Euler's modified. Just you can try for, because just approximation we will get for y1, y2, y3. Here notation is different, y minus 1, y minus 2, y minus 3. Okay, these two formulas are very, very important. So remember this formula, because this for prediction and correction, formula should be very right. If there will be any misprint in the formula or miswrite, then answer may be different, may be wrong. Okay, so remember this two formula, prediction and correction formula from Adams-Bashforth. Milner's are different formula. Okay, for prediction correction. Now just take a question. Here solve the initial value problem, dy by dx equal to x minus y square. So solution, you want dy by dx equals to dy by dx equals to x minus y square, y0 1. This is given. Okay. So just we can write these values here. Given dy upon dx equals to x minus y square, and this is initial condition. This is given. Okay. And we have to find y.4 by Adams method. Starting solutions required are to be obtained by using Ranga-Katta method of order 4 using a step value h equals to 0.1. So here just in the questions it is given that the starting value, that is previous value, just you have to find from Ranga-Katta method. Okay. So and we have to find y.4 and taking a step what point h equals to 0.1 also given. So that means what? Here initial value of x is what? Initial value of x is 0, 0 and y 1. This is given. Okay. So just for notation, at the time of Adams-Bashforth formula, we will write in different order, but here x0, this at x0 we will get y1, not get, this is given. Okay. Now here it is given that h equals to 0.1 is a step, and our required value is what? Y 0.4. This is we have to find, and a step is 0.1 and initial value is 0. That is what? Initial value is here 0. This is x0, this is x0, 0, and y0, 1. This is y0, 1. Okay, and we have to find y.4. That is, and step is 0.1. That is, if this is 0.1, this is 0.2, this is 0.3, this is 0.4. So this is x0, this is x1, this is x2, this is x3, this is x4. That is, we have to find y4 as previous notation if we use. But here in Adams-Bashforth formula, we will find y1. Okay, our notation will be in reverse order, but value will be same. Here x3 means it will be what? x0. Just for notation only, it will be x at x0, y0. Here at x1, y1. Here -1, -2, x -3, and here -1 or -2 by -3. This will be our notation, but value just now we will find here y1, here y2, here y3. But taking this initial value, we will get the value this. By using this, we get this. By using this, we will find value this by Ranga-Katta method. Clear? In this interval, we use Ranga-Katta method to find y1. That is denoted by y-2. For this interval, just use this as a initial value and we get y 2. This is denoted by this in Adams-Bashforth method. So now we will use Ranga-Katta method for finding y1, y2, y3. Clear? And here also y3. This is denoted by y0. This is y0. This is denoted by y minus 3 in Bashforth formula, Adams formula. Okay. Now our first target is y1, y2, y3 finding. Okay. So just use the previous notation only. Y 2, 3, 0.1, 0.2, 0.3 we can use. Okay. So here, by using Ranga-Katta method, we have to find the value. Here initial value is given 0.0 like this. Now our find technique of will be what? Ranga-Katta method. So here given fxy equals to what? This x minus y square. H equals to 0.1 and initial value x0 equals to 0 and y0 equals to 1. These are given. A step is this x0 0, y0 1 and fxy go to this. Now Ranga-Katta method. Okay. To find at 0 we know, after 0 point at point 1. So to find f not f, y point 1. We have to find this now, just like this 0, 0.1, 0.2, 0.3, 0.4. Okay. Now y0, this y.1 we have to find by Ranga-Katta method. To find this by RK method. Only RK method means what? Ranga-Katta method of order 4. Just find K1. K1 equals to what? K1 equals to, we know, just we have to find K1, K2, K3, K4 and then find K and then y.1 equals to y1 equals to y0 plus k. That is the answer, we know. So first, what? H, F, x0, y0. H means 0.1, 0.1. Just this is formula. Formula is main thing. Okay. So here just write formula first. What? F x0 plus half H half y0 plus half k1. Here H x0 plus half H, y0 plus half k2. Here H, F x0 plus H, y0 plus k3. Just we have to find the value. Okay, and then this. So we get, just find one by one like this, these and just this is our format for finding values of y at targeted point by using Ranga-Katta method. This is our formula. This formula is what? 1 by 6 K1, K2, K3. What is the formula? K1, K2, K3, K4, 2, 2 in between, 1 by 6. K1 plus 2K2 plus 2K3 plus K4. This is the value of K, and by use this value here, we can get value. Okay, so here point H, point 1, x0, y0, 0, 1. So F 0, 1. You can use this formula. So 0 square minus 1 square. 0.1 into 0 square minus 1 square equals to minus 0.1. This is value of K1. This is value of K1. Just now similar process you have to do. Okay. Here 0.1 f of x0 plus half h means x0 is 0 plus half h 1 by 2 h means 0.1. This first value. And y0 plus half k1. K1 is this minus 1. So y0 means what? 1. So 1 plus half minus 0.1. Just 0.1 into f of, just you can solve it. What will be the value? 0.05, 0.95. 0.05, 0.95. Now, this is equals to what? 0.1, 0.05 square minus 0.95, not a square, x minus y square. So this is a square. Now calculate it by using calculator. You can get the value minus 0.8525 minus 0.08525. So this is the value of K2. Similarly, you can use this formula. Just put here what? In place of K2, just use this formula. H means what? 0.1 f of, you can get x0 plus half h, that means 0.05, 0.05, and y0 plus half K2 means 1 plus half this, 1 plus half of minus 0.08525. This can be solved also by using this formula. You can get the value 867. 0.0867 minus 0.0867. So this is the value of K3. Similarly, you can get the value of Y. Just use calculator. You can solve by using this formula. Finally, value will be this. Okay. Now here K4. K4 means what? H. 0.1. Fx0 plus h. X0 means 0 plus h means 0.1. So 0.1, 0.1 and 9137. Here 1 plus y0 plus k3. K3 is this. Minus of 0.0867. So just using this you can solve and find the value. By using this you can solve this just like 0.1 comma 9137, 0.9137. Okay, now apply formula. 0.1 into 0.1 minus 0.9137 square, and you can get the value as 7341 minus 0.07341. Okay. So one by one you can find the value. So this is K1 is this, K2 is this, K3 is this, and K4 is this. So just use here. for finding the value of k. So this is equals to 1 by 6, 0.1, k1 means minus 0.1 plus 2 times of k2. K2 means minus 0.08525 plus 2 times of plus, okay, k3 0867 minus 0.0867, here minus 0.07341. These are the values. Just putting values you can get. Just solve it. Now multiply, add, subtract, divide. By doing this you can get value as what? By using calculator, 0.0883 minus 0.0883. This is the value of k. Thus y.1 equals to y1 equals to y0 plus k. y0 plus k means what? y0 1. So 1 plus k means point this 0.883. So this is equals to 1 minus this is equals to, final value is 0.9117. 0.9117. This is the value of y.1. y. This is in the first interval. In this first interval, 0.1. Here we get value y1. y0 is given. Now for point 2, for y2, we will use, for point y1, just we use initial value of this. Now for point 2, we will use this value. Formula will be differ. Okay, so in the next interval, so we have found the value of, just like x equals to 0, y equals to 1, x equals to 0.1, y 0, y1 equals to this 0.9117. Just first value is given value, okay, second value is what? This is x0 equals to, and this is x0 plus h equals to, this is x0 plus h, 0 plus 0.1. This first value we have found. Now for second, for y.2, this is y1 means y.1. Now to find second value y.2, for this, by RK method, same process will repeat. Just formula will have x1 in place of x0. Okay, same process we will carry for the next interval. For finding y.2, formula will be what? Same formula. Just in place of x0, here x1 will be there. x1 for next step, because here x0 y0 initial value we have used. Here for y2 just x1 y1 will be used. In place of x0 y0 just we will use x1 y1. X1 y1. Okay. Clear? Now for next value here also 0.2 2 1 this. So this value will be used. Clear? x1 equals to 0.1 and y1 equals to 9117. Now we will use this value. First time x0, y0 were used. Now we will use x1, y1 equals to x1 0.1, y1 0.9117. Clear? Just now we can use this formula. Same formula will repeat for finding y. Clear? Just here h equals to 0.1, f of x1 means 0.1, y1 means this 0.9117. Just we can use formula what? This 0.1 minus 0.9117 square, and we can solve it. So we can get the value 0.731 minus 0.0731 minus 0.0 minus 0.0731. Okay, so this is the value of K1 in the next interval to find y2. Okay. Similarly, just we have to find all the values k2, k3, k4, k, and then we can find the value of y2. Okay, this is the Rangakutta method. Same process will carry in each interval by taking previous value, just x1, y1. Okay, so we can also find the value of this. Just use these values. H equals to 0.1 and here we can write like this 0.1 f of what? x1 plus half h. 0.1 by this. Just write x1 what? 0.1 plus half of 0.1 comma this y1 this 0.9117 plus half of k this minus 0.0731 is this. Just use this formula and you can get the value k2 minus 0616 minus 0.0616. Okay, just calculate it. This is square minus this square. Okay, similarly 0.1 f of 0.1 plus half of 0.1 and here y1 is this 0.9117 plus half of this 0.0616. This can be found also 626 minus 0.0626. Just use calculator, you can get the value using this formula. Okay, here h 0.1 f of x1 plus h 0.1 plus h 0.1. Okay. Now y1 0.9117 plus half of, not half here, not half here, y1 plus k3, that plus minus 0.0626. Just again solve and use this formula. You can get a4 5 to 1 minus 0.05 to 1. Okay, this k1, k2, k3, k4. Now just put here. You can get the value 1 by 6. k1 means 0.0731 plus minus 0.2 times of plus 2 times of, just you can write like this, 2 into, okay, 2 into minus 0.0616 plus 2 times of minus 0.0626 plus minus 0.0521. This. Just multiply and add and divide, then you can get the value of k as 6 to 3 is equals to minus 0.0623. 0.0623. 0.0623. By using this value, we can get the value of y2 as y1 what? 9117 plus y1 9117 plus this 0.0623 is equals to what? Just subtract it. y1 plus k 8494. 0.8494. This is y 0.2. Just next y2. Okay, that is y2. So we get what value? y2 for corresponding to x0 plus 2h equals to what? 0.2. y2 equals to what? Just like this, 8494. 0.8494. Okay. Now next value y3 for 0.3. For this, just change the value here. For finding 0.3, just we will take just previous value, that is x2, y2. So x2 means what? x2 means 0.2. So x2 equals to 0.2 and y2 equals to 0.8494. Okay. Now we will take x2, y2, 0.2 and y2 equal to this from point here, just for getting y3. Here formula will be changed in place of 2, just 2. Okay, again repeat this for finding y2, y3. So here just you will carry this same process for finding value of y2. Okay. A formula will be changed, just like in place of 1 we will use 2 for finding y3 here y2. Same process will carry. Now initial value will be this. So h is same 0.1. F of x2 means 0.2, y means this 8494, we can get 0.1 into what? By using this formula, 0.2 minus 0.8494 square, and solve it. You can get the value K1. Five to 1 minus 0.0521. Just as the same process, do this. Okay. Here also only x2 are there, na? x2, 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 x2. Formula will carry same formula in the next interval. So here K2, 0.1 f of x2 plus half h, 0.2 plus half of this first way, and second y2, this 0.8494 plus half of K1, this minus 0.0521, and you can solve it. Just solve it. This first value x, solve it. This second value y. So x minus y square, this minus this square into 0.1 is equals to, we can solve and get the value 428 minus 0.0428. Similarly, for K3 and K4, we can get the Ranga-Katta method for finding three values, y1, y2, y3. Just now we are finding y3. Here, K3, 0.1 f of this x2, 0.2 plus half of same 0.1 as previous now. Then 0.8494 plus half of just this value minus 0.0428 is equals to 428. Huh? Yes, 436 minus 0.0436. Just use calculator and use this formula, then you can get the value of f. Okay, here again finally f of plus h only, so 0.2 plus 0.1, and here 0.8494 plus just K3, 0.436, and also solve by calculator. Then for this is 349 minus 0.0349. Clear? These are the K1, K2, K3, K4. Now find the value of K and then add, then you can get Y3. So 1 by 6, just K1, that is minus 0.0521 plus 2 times of K2, that is this minus 0.0428 plus 2 times of this minus 0.0436 plus this minus 0.0349. This. Just solve it. Okay, multiply and add and divide by 6, you can get the value of K as 438 minus 0.0438. 438. So these are the calculation. Numerical method is just you use calculator, and maybe computerized computer will do the first calculation. Okay, so here y2 means 0.2 plus value of k is this 0.0438, and this is equals to, finally we get y3 0.8061. 0.8061. This is at y3. Clear? y3 y3 equals to this. Clear? So this is y3. x0 plus 3h equals to 0.3 and y3 equals to 8061. 8061. So these values we have found by using Rangakatta method. The same process we will carry for 3 interval. Now for getting this value, just using Adams-Bashforth predictor formula. Okay, so here now we will write like this. The starting value we have got. Okay, so starting value, corresponding to starting value, we will find the value of f 0.23, f minus 1, f minus 2, f minus 3. Here notation will be changed. Okay, so for that, just we have to write like now. The starting value values of Adams method with h equals to 0.1. First value x equals to 0. Second value x equals to 0.1. Third value x equals to 0.2. X equals to 0.3. Y equals to, now our notation is clear. Our notation will be in backward direction. So here y0, y minus 1, y minus 2, y minus 3. X equal to 0.0, this 0.0. Y equals to, y0 equals to what? 1. So we can write corresponding to 0. Notation is changed only. So here 1.0000, just write 40 because 4 decimal places are used here. Okay. Now for x equal to 0.1, 9117. So just differ notation. So here we have to write 0.9117. Clear? Now for 0.2, 8494. So 0.8494 and 0.8061. These are the notation now. Okay, 8061, 8494. Okay. Now corresponding f1, f2, f0, f minus 1, f minus 2, f minus 3 we will find. Okay. So here this is the notation just for Adams-Bashforth Predictor Corrector method or Adams Predictor Corrector method. Just starting values we have got like this 4 values. Now our calculation will be by using here also f xy equals to what? X minus y square. This. So here we have to find f minus 3. F minus 3 equals to what will be the value of f minus 3? We know f minus 3 equals to means f minus 3 equals to means just using this x and this y. By using this formula, we have to find the value of f. So x is this, that is 0.0 square, sorry, this x minus y is this 1.000 square. Just we can find the value. What is the value? Minus 1. Minus 1.000. This we can write. Okay. Similarly, just we have to find f minus 2, f minus 1, f0. Here f2 for this x or for this y, that is 0.1 square minus 0.9117 square equals to, here 0.2 square, sorry, not a square here, minus 0.8494 square, here 0.3 minus 8061 square. Just find all the values. Just use the formula. And f minus 1, minus 2, minus 3 and so on. Okay, so 7312 minus 0.7312 and minus 5215 minus 5215 and minus 3498. Just use calculator, you can find the value. This is f minus 3, minus 2, minus 1, f0. Okay. Now we will use Adams-Bashforth predictor formula. Using Adams-Bashforth predictor formula. The value of y1 is given by, what is the formula? y1 predicting value of y0 plus h upon 24, first value f0. What is the first value? f0, f minus 1, f minus 2, f minus 3, 55, 59. Just formula is main thing. You have to write formula correct. Okay, 55 f0 minus 59 f minus 1 plus 37 f minus 2 plus 37 f minus 2 minus 9 f minus 3, 9 f minus 3. Very simple. Just put all these values here. 0, minus 1, minus 2, minus 3. 0, minus 1, minus 2, minus 4 values are used here. And h equals to 0.1. And y0 equals to what? You know, 1. Clear? So just put the value here. y0, sorry, not y0 equals to 1. y0 equal to this 0.8016. So use this value here. 0.8061 plus 0.1 upon 24. 55 into f0. f0, what is f0? This. Minus 3498 minus 59 f minus 1. 3498. Okay. And f minus 1. So this value minus 0.5215 plus 37 of this value minus 0.7312 and minus 9 into f minus 3, this minus 1.0000. So this is the substitution of values. Okay. Prediction. Just calculate it. You can get prediction value like this. What is the value? 7789. 0.7789. 0.7789. So this is the prediction value. Clear? This is the prediction value. Now we will use correction. Corrector formula. Correction. We will refine the value, this predicted value, by using corrector formula. And corrector formula, for corrector formula, we will require F1. F1 will be found by using this Y1 and X1. X1 equals to what? X0 plus H. That is, this is now X0. This is X0. This is X minus 1, X minus 2, X minus 3. So X0 equals to 0.3. So 0.3 plus 0.1 equals to 0.4. This is X0. Now value of X1. So now X equals to 0.4. X equals to 0.4. And Y1 equals to this. Y1 predicted value is this. 0.7789. Now for this X and Y, just by using this formula, we can find F1. Therefore F1 equals to, what will be the value of F1? X minus, that is 0.4 minus this Y1, predicted value 0.7789. You can solve it and get F1. Okay, so F1 equals to 2067 minus 2067 minus 0.2067. This is F1. Just okay, by using this X and this Y. Now this F1 will be used for correcting the value. Okay. Now this prediction, one time you have to predict the value. Now correction. Now using Adams-Moulton's corrector formula, the value of Y is corrected as formula is different. Okay, so remember this formula for Adams correction. Okay, so formula is what? For correcting formula, correction formula, Y1C. Correction formula is Y0 plus H by 24 9F1. Y0 plus H by 24 9F1. Y0 plus H by 24. The correction formula is also important. Y0 plus H by 24 9F1 plus 19F0 plus 19F0. 9F1 plus 19F0, 9F1 plus 19F0 minus 5F minus 1. Minus 5F minus 1. Minus 5F minus 1 plus F minus 2. Plus F minus 2. This is formula. minus 5f minus 1 minus 5f minus 1 plus f minus 2 plus f minus 2 9f1 plus 19f0 1 0 minus 1 because 1 we have got the value 1 f, so just previous 4 value f1 0 minus 1 minus 2 f1 0 minus 1 minus 2 9 19 minus f 5 9 plus 19 1 0 minus 1 minus 2 9 19 minus 5 9 19 minus 5 plus f2. This is formula, just remember. Okay, now using Adams-Bashforth corrector formula, the value of y is corrected as first time correction. This formula is used, so this is equals to y0. What will be the value of y0? This 0.8061 plus 0.1 upon 24. This. Now in bracket 9 into f1, just this f1 will be used, minus 0.2067 plus 90. Just use like this f0 is this minus 0.3498 minus 5 f minus 1 this minus 0.5215 plus f minus 2 this minus 0.7312. Clear? So just solve it, you can get the value. Okay, 7312 521 3492 and this 7785 equals to 0.7785 0.7785. Okay, so this is y1. Clear? y1 means y at 0.4 implies, hence the corrected value of y1 is y.4. At 0.4, y1 is 0.4. 7785. This is first time correction. You can do correction repeatedly. Again you can use this formula. For that you have to find the f1 repeatedly. How can you find the f1? This is the value of y and value of x is what? 0.4. Value of x is 0.4 and y is this. So for this x and for this y, you can get the value of f. Again f1. That f1 can be used here. Only f1 will be changed. And again use this formula. You can get new y1. Another correction. And doing this process, you can get first, second, third, fourth, fifth correction. Whenever two correction gives same value, that will be the more accurate value. So this is corrected value. Okay. So this is the process. So corrected value is this. Okay. You can do the correction 2, 3, 4, 5, 6 times also. So correction is, first of all we have to predict and then correct the values. Okay, so prior values can be found by using any of the methods, but Ranka-Kutta method is good for greater accuracy. Okay, with Adams-Bashforth method. Now, just there is questions for you. Just solve it and send me for your attendance. Okay, just I will give hints, a very small hint for these questions. Okay, so for your attendance, the question is Here the given in the given questions it is given that the prior values, the starting values, you have to find by using Euler's modified method. But remember that you can find starting values by any of the method, previous method, Euler modified, Taylor's, Rangakatta and Picard's methods. Just I think Rangakatta method is very simple, but calculation is lengthy. Something if there is three values, okay. So just you can use any of the method, previous method, for getting starting values. So in these questions, it is given that use Euler's modified methods. You know modified method. Here in these questions, it is given that. So dy by dx 2 e to the power x y0 2. Here dy by dx equals to 2 e to the power x. The question is given like this: dy by dx equals to 2 e to the power x y and y0 2. This is initial value problem. Okay, this is given initial value problem. We have to find y4. We have to find y4 and using Adams predictor corrector formula by calculating y1 2 3 using Euler's modified formula and y1 y2 y3 these three values you have to calculate by using Euler's modified formula in these questions. You can use also Rangakatta method, but in this question given that you use Euler's method, modified methods. You know Euler's modified method, very simple. In this method also you can use what? This is x0 y0, okay, point. Here next point, first value is 0. So here value is here 0, x0, okay, and next value is 1, then 2, then 3, then 4. This is our targeted value. This is our targeted value. So in this interval, we have to use Euler's modified formula. And Euler's modified formula, you know, the formula is what? Just by taking this value, that is this value, we are starting, and by preparing a table, we can get the approximation in each interval for getting the value at y1, purifying by taking approximation. Same by using this value here, we will do same process, and also here we will do same process. Then we can get y1, y2 and y3, and this is y0. So these are the four values. This y0, y1, y2, y3. For Adams-Bashforth formula, just we have to write it in reverse order. Y minus 3, y minus 2, y minus 1, y0, and we will find y1 by Adams formula. Clear? This value can be found also by Rangakatta method. But Euler's method, for Euler's method, you know, we are preparing a table just like here value x, and then first value, first column contain value x, and second y dash 2 to the power x, y, this y dash, and third column what? Mean slope, or here old y plus h into mean slope equals to new y. This was our Euler's modified formula. Just like here in this formula for here point 4 is this, point 1, point 2, point 3. So we have to find point 1, point 2, point 3, point 4. Why point 4? Point 1, point 2, point 3, point 4. Okay, so starting from 0, 0. Then point 1, point 1, point 1, point 1. This is our approximation. Just use value. How? X equals to 0 here. Use. And y equals to 2. 2 to 4. 4. This is 4. And just mean slope first and not. Old y, what? 2. Plus h, what? Taking h, a step. How many step will be there? H will be, h is equals to what? 0.1. So, 0.1. So, 0.1 plus 0.1 into mean slope. Means you use 4. Now here, 0.1 into 4, 2.4. 2.4. 2.4. Similarly, just how we use this values here, x equal to 0.1, x equal to 0.1, 2 e to the power 0.1 into y, y equals to what? Just previous value is used, okay, y, this is new y, so here 2.4, understand? This is was the Euler's modified formula, just new y is there, so here y, in place of y, 2.4 e to the power 0.1, and this value will be what? You can calculate 5.305. 5.305. This is y dash means slope, and here mean slope is half of the slope. This slope and previous slope. Previous slope means what? Previous slope was this and this. So 4 plus 5.305. 5.305. So 4.6524. 4.6524. So just you have to calculate it. And now this is mean slope. Previous old y2 plus mean slope 0.1 into mean slope 4.6524 equals to, you can calculate 2.465. 2.465. Just do this process up to 1, 2, 3, 4 times. Whenever two values are just like same, then that will be the value of y at point 1. Y at point 1 means this value. This value. And next step, and then start next step. This is in first interval. And for the next step, just use here 0.1 first time, because previous value will be used, and the slope, this slope will be used here, and here will be dash, and this formula also carry up to and 0.1, and then 0.2, 0.2, 0.2, and step complete, and then start from 0.2 and then 0.3, 0.3, 0.3, and this is the Euler's modified method. By using this method, you can get these three values, and after finding these values by Euler's method, just write how. X zero, 0.1, 0.2, 0.3, and find y -3, -2, -1, 0. Y0 will be this, and what this value can be find. Just we have find this value here. This, and 0 is given value this, and corresponding to this, you can find the value x y equals to what? 2 e to the power x y. Just use this x and y here, then you can find f -3, f -2, f -1, and f0. By finding this value, just correct, find the next value. What? y1, that is y.4. Just Adams-Bashforth predictor formula. What is predictor formula? Let's just remember this formula. Okay, always. What y1? y1 means what? y.4 predictor formula is equals to y0 plus previous value h upon 24. H equals to here 0.1. So just like 55, 59, 37 and 9. These are the formula. Here minus sign, here plus sign, here minus sign. Here f what 0, f what minus 1, f what minus 2, f minus 3. This is formula. Okay. 55, 59, 37 minus 9. 0, minus 1, minus 2, minus 3. 0, minus 1, minus 2, minus 3. Writing method. 55, 59, 37, minus 9. Plus, minus. 0, minus 1, minus 2, minus 3. So this is the formula. Just use here value. y0, that is this. And all those values. You can get the value predicted value. And after prediction, just for x equals to. After prediction, just for x equals to what? 0.4. And y, this prediction value. For these two values, just find f1 equals to. And then Adams-Moulton corrector formula. What? y1c, correcting, value correcting. What? y0 plus h upon 24. Just here, what is the value for writing? 919.5. 9f1 minus plus 19f minus f0. So f0. Just previous three value and f1. f1 this. And minus 5 f minus 1 plus f minus 2. This is formula. Okay, 9f1 plus 19f0 minus 5 f1 f minus 1 plus f minus 2. Just use this f1 here and these three values are here and h 0.1 y0 is this. Just you can get first corrected value and then you can correct 2, 3, 4, 5 times. Just repeating these values by finding new f1 by using this y, this first corrected value and this x equals to 0.4, this value x1, y1. Using this you can get new f1 and by using this f1 here you can get a new correction. So 2, 3 times correct the value and finally nearly 2 corrected equal correction will be the value for y.4. Okay, so do it and completely do it and send me PDF for your attendance. Okay.